Well, good morning, good afternoon, good evening, everyone, depending on where in the world you are. Welcome to today's Fireside Chat. My name is Brandon Satram, and I'm the Senior Vice President of Product and Experience for Blues. Blues is a hardware and services company that is on a mission to simplify wireless communication and remove the complexity associated with building, deploying, managing, and scaling connected solutions across all major radio access technologies from cellular to Wi-Fi, LoRa, and satellite. And I am joined on this fireside chat today by Marcello Majonchi from Arduino. Marcello is the Chief Product Officer. And Marcello, if you want to take a moment and introduce yourself, welcome.
Thank you, Brandon. I'm really excited to be here and, really excited to have this chat with you. So I'm Marcello Majonchi. I'm Chief Product Officer at Arduino. And, in my role, I kind of oversee the entire portfolio of products that Arduino, delivers from hardware to software and cloud.
Right. Thanks, Marcello. So I would love to hear a little bit more about your journey into the IoT. I think it's always interesting to hear how people found themselves in this space. And so I'd just love to hear about what brought you into the space in general, and then eventually to Arduino to join the team there.
Oh, absolutely. So at this point, it feels like I've been in IoT forever, right? And as a matter of fact, I started in IoT without, even realizing, because I was, of course, I spent a life in tech, and at some point I was in a small startup working on, some networking SaaS product, and only afterwards I kind of realized that, there was a component of connected, devices that were managed by a remote, SaaS service, and it was basically IoT, and that was before the IoT was even a mainstream thing. And after that, I've been involved in a couple of other startups, building one of the very first SaaS IoT platforms that led to the company being acquired by Microsoft, and that started my corporate career journey with Microsoft, AWS, and a bunch of other companies.
Very nice. And then what eventually led you to Arduino?
Well, I'm Italian. I'm in IoT. It's almost like it was supposed to be. No, I've always been, been a big fan of Arduino. Actually, the fun fact is the very, very first IoT project that I did in the startup that we ended up selling to Microsoft was, supporting a customer that was looking to connect their machinery to the cloud to do predictive maintenance. And the funny thing is that they actually had prototyped, and I'm talking back in 2015, 2013, they prototyped the whole thing on Arduino. Right, and that was the first time that I really realized that Arduino was not just something that people could tinker with and play with, but was something that was seriously useful for companies and enterprises to be able to innovate in a much faster and effective way. And when I got the opportunity, right, chatting with the CEO and the founders to kind of join and bring a little bit of my experience to to the cause, it was too interesting of an opportunity to pass on, and here I am.
Oh, absolutely. Yeah. Well, that's fantastic. One of the things that I love about the ecosystem that Arduino has created, millions of developers. I think you yourself had told me at one point that if you looked at all engineers out there on LinkedIn, I think 1 in every 4 has put Arduino in their LinkedIn profile. So 25% of all engineers have done something with Arduino. Of course, is that stat right?
I don't think that is 1 in 4, but it's a very high number, right? I think that
all right, maybe
we are close to several millions of people on LinkedIn that have that site Arduino of their skills, and I would say that right now, based on the latest estimation, we think that the active developer ecosystem of Arduino is in the ballpark of 34 to 36 million developers around the world, and growing.
Absolutely. Yeah. Well, that was my experience as well. I mean, I spent the majority of my early career primarily as a web developer in the late 90s and going into the early 2000s. And then it was somewhere in the 2014, 2015 timeframe where I picked up my first Arduino board, and really immediately, like millions of other developers, was like, this is what I've been looking for. This is so much easier than anything I've messed with previously, and just sort of fell in love at that point and moved on. And I think what's really interesting about Arduino's journey is the way that maps to then those same, what we had talked about for years as sort of being the maker community, that so many of us are professionals. Those makers are professionals working in industrial settings and working for large organizations by day. And obviously Arduino spotted that opportunity because you all moved into the industrial space and created the Pro line. So describe that genesis. What was the sort of the intention or the purpose that led you all to expanding into the Pro market?
Yeah, that was exactly that. The founders and the management team at some point realized that Arduino was not only the de facto platform for makers that wanted to kind of to learn and create new stuff, but also for
Hmm.
enterprises and professionals that wanted to use a platform that would abstract the complexity without obfuscating the possibilities in order to
Hmm.
prototype and innovate. But of course, the observation was at the same time that the same hardware that originally was meant just for kind of prototyping and tinkering sometimes were actually used in production, right? And
Hmm.
others that wanted something more robust were actually dropping that and choosing to do chip down design or other solutions in order to be able to be in production with that. And so they spotted an opportunity to really support and follow Arduino enthusiasts and Arduino professionals beyond this initial phase. And this is why and how the Arduino Pro line was born, right? To really, keep supporting innovators in their journey beyond just the early stages of prototyping, but still kind of, being able to support them in that stage, but following them
Hmm.
into, production and scaling their projects.
Yeah, absolutely. So that the journey into the pro line, I think, was interesting, and one that I observed from afar as well. And it seemed like exactly the right move from Arduino. And then that next step of moving into the Opta itself, more into sort of the finished solution or PLC space. What was the customer feedback or sort of the opportunity that you all observed that led to then taking that step?
I think that kind of follow a similar kind of thinking process, right? In the sense that the
Mm,
industrial automation market is at the same time very mature, very popular, but also traditionally quite conservative, right? And at the same time,
sure.
they realized that there were a ton of people that were trying to kind of solve automation problems using Arduino technology, right? And they were kind of missing that the step to be able to be supported in production with the same open, accessible, and scalable approach that Arduino
Mm,
has popularized. And so, as a consequence of that, is in partnership with a very well known automation firm in Europe, we actually developed the first Opta, which is this device here, which is
mhm,
meant to be what we call a micro PLC, right? That
mhm,
combines best of both worlds, right? It's something that can be approached both from an automation background. I can use my traditional automation languages like ladder logic and IC 6 3341 3411,
mhm.
sorry, for programming it, but also at the same time I can use Arduino and Arduino, the Arduino libraries to be able to to program on that. So it really gives a new and more approachable way to traditional automation engineers to enter into the Arduino ecosystem, but also gives a way for the Arduino ecosystem to get into automation at a much
Absolutely.
lower with a much lower bar of entry in general.
Absolutely. Well, I know for me as a traditional programmer, as a the embedded work that I've done has all been in C, C++, and Arduino. And so having that as a rather than having that, the need to learn ladder, to learn function blocks, to learn structured text, that I was able to approach building a PLC kind of prototype or solution using the Arduino IDE was very appealing. But I do also, like you said, love the fact that for the traditional automation engineer that those languages are there, that the ability to take that same concept of something you're using on a different PLC and bring it into the micro PLC in that space is really nice. And I think that it seems to me, based on conversations that I've had with developers and engineers at events, that it's a pretty even split. A lot of folks use Arduino, a lot of folks use the IEC languages on the PLC. So it's not, it seems to have served both audiences pretty well.
Yeah, and I would say that there are some, actually many, that use both, which is another kind of
Which
nice
is
add,
cool.
right?
Yeah.
The fact that you can extend your ladder logic program with Arduino sketches in order to make it easier, for example, to connect to the cloud or to do something more
Yeah.
advanced or more modern that
Yeah.
would not be super easy or super aligned, right, with ladder programming. I would say, Brandon,
Yeah.
that it really, especially from an enterprise point of view, right? It really caters to the core needs, right? On one hand, they need to have something that is flexible but plays into the existing ecosystem, right? Chances are that this company
Hmm.
already have PLCs deployed,
Hmm.
but at the same time, it's also addressing what we call the talent shortage for automation development, which as a matter
Absolutely.
of fact is the only development skill that is actually shrinking, right? There are less and less automation developers out there because, of course, right,
Hmm.
newer generations are less likely to actually focus on those technologies, and they
Right.
would rather go on C++, on C, or on kind of more modern languages
Hmm.
and frameworks.
Hmm. So what are some examples of the kinds of solutions that you're seeing engineers build with the Opta? What have been some surprises, or what have you learned now that this has been out in the wild?
So every day is a surprise, right? Because we got a
Yeah.
ton of different use cases. The reality is that Opta was from the beginning engineered to be what we call a Swiss Army knife for kind of PLC and
Mm.
for automation. And so really it
Hmm.
really plays well because of its flexibility into solving many different scenarios and many different needs.
Hmm.
And so what we see is the widest variety of applications, right? From people that are using Opta for building automation and home automation to be able to control lights and HVAC systems. As a matter of fact, this is also what we do at Arduino in our own office
Hmm.
in Torino. But also companies that are using for retrofitting in industrial equipment, for example, by
Hmm.
leveraging the digital and analog IOs that you have on the Opta or with the expansion that you can plug on. But also kind of it spans for, packaging machines, industrial kind of, cooking equipment, air compressors, you name it. I think that, almost every industrial piece of equipment at this point, in some, place of the world has been connected to an Opta and, more often than not brought online, thanks to this platform.
That's great. And you mentioned the expansions. That was going to be my next question. So, what was the genesis behind building in the expansion
Oh,
ecosystem as a part of
sorry.
this as well?
Oh, it's blurred.
Yeah, no, I
So
can see it. That's great. Yeah.
yeah, and this is kind of the idea to be able to really provide a plug and play, right? Expandable ecosystem because the observation here is pretty straightforward. First, Opta is packed with features, right? It has
Hmm.
connectivity, Ethernet, Wi-Fi, Bluetooth. It has I/Os, digital analog relays. It can deal with industrial protocols such as Modbus RTU over IP. But of course, you always need more, right? And so the
Hmm.
original kind of the original concept of Opta, we actually plan to have an expansion port, right, an auxiliary port to be able to plug in additional capabilities. And we started by developing a few expansions ourselves, like the one that I'm seeing here, that is extending the IOs, right? We have digital and analog versions, for digital inputs and outputs, and analog inputs and relays. But then, of course, right, different automation scenarios require different add-ons potentially, and this is where kind of
Hmm.
we started working with with Blues, right, thinking about expanding not only the I/O capabilities but also the connectivity capabilities of Opta in order to provide more and more flexible and more kind of effective ways for customers to be able to to bring online their automation systems.
Yeah, and
So there
that's
it
a
is.
great segue because that was, part of our conversation here was to also discuss the partnership between Blues and Arduino, which is something that we have been working on since late last year, as our two CEOs got together and talked about what was happening in the Opta world and the opportunity with connectivity. And so, for those of you on the webinar, the product that I'm showing here is a expansion for the Opta that uses that same connector that the expansion modules that Marcello shared, uses those exact same connectors and brings in wireless connectivity not native to the Opta itself. So specifically cellular or LoRa, if that's something that is useful in a deployment in an environment that you're working with. And so this is something we're excited about because we've been pursuing it for a while. And I I think this has been really neat because when Fabio, Arduino CEO, first mentioned this to us, I think a lot of what he was seeing and you all had been seeing at the time is that there was a growing need for providing another set of wireless connectivity options among some of your customers. And I would definitely love to hear from your perspective, Marcello, not only what have you seen, but also how do you feel like this partnership sort of helps Arduino really solve more of those key problems in the pro space?
Yeah, the way that I frame right what the combination of the Blues wireless expansion for Opta brings to the market is frictionless connectivity, right? Because and this is not
Mm-hmm.
just for Opta, right, but for anybody that has been in industrial IoT. One of the major complexities of deploying at scale IoT in the industrial kind of world is dealing with the complexity of getting connectivity, right? Even
Mm-hmm.
getting an Ethernet cable with an IP address in an industrial factory floor can be very, very hard. And I've seen in my own experience in the past many projects failing because of that, right? And so there are many cases
Mm-hmm.
where the ability to have a literal plug and play deployable solution where you kind of plug the devices, put it on your DIN rail, give power, connect it to the machine, and it just works.
Mm-hmm.
It's game changing. As simple as it sounds, it's not something
Mm-hmm.
that you find that often and that commonly out there. And I think that this is probably, and quote me on that, but of course it's kind of my opinion. This is one of the most accessible, right, solution for industrial automation as the combination of integration, connectivity, and potentially cloud integration to the market today.
I agree. One of the things that I've observed as I've talked to automation engineers, like when we were in the booth with you all at the Automate event in Chicago in May and other places, is how often the answer to the question of, well, how do you do connectivity with this other PLC system that you're working with now? It's a custom effort. It's a design build effort of 6 to 9 months in order to add a connectivity module, even if it's just Wi-Fi to begin with. But one of the things that I observed in the booth we saw again and again was the people that came up and said, "Gosh, I love the Opta. I think what you guys are doing is great because you're coming in at a price point that makes this class of automation solutions possible for me that I couldn't justify before because of the cost of other systems out there." But at the same time, they would say, "But I can't get an IP address for Wi-Fi. I can't get Ethernet access. What are my solutions?" And so to be able to expand that connectivity with the Blues expansion model, whether it's via cellular with LoRa, we're excited about, and we're definitely hearing that from customers as well, is that actually solves a key piece. And what we like to say is sort of the OT IT war of, but giving operational technologists and automation engineers the ability to get something connected, even if it's just to prove the value of a solution before they go through the full on rigmarole of getting things connected previously. And it always makes me think of, and this is part of my history in technology, but it makes me think of the similar sort of revolution in personal computing in the enterprise and what we sort of called the consumerization of IT in the late 90s and early 2000s, where putting access databases and front page in the hands of non-IT organizations allowed them to solve a problem, to solve a key problem without a big expense and without a big delay. Are you guys seeing a similar thing? Is that sort of what you're hearing from customers in terms of what that unlock is for them?
Absolutely, right. And kind of I'll
Yeah.
go back to something that I was asked, a few years back, right, about my take of what was the best IoT, architecture out there. And my answer was that
Mm-hmm.
is that whatever architecture that is easy to deploy at scale. Because at the end of the day, right,
Mm.
because of all the complexities of IT and OT technology combined, again, the main obstacle to success is being able to have something as simple as it can be, right, that works
Mm-hmm.
in the field, is maintainable in the long term, and
Mm-hmm.
is doable, right, from a logistic perspective, right,
Mm-hmm.
and I think that this is something that addresses that, and this combination, right, this joint value proposition and between Blues and Arduino Opta really address this basic need, and we are already hearing a lot of customers that are now able to enable their use cases because of this,
Mm-hmm.
right? Because it was
Yeah.
something that
Yeah.
was just too hard to do or too expensive to do with traditional technologies, or the management overhead was not justifying right the benefits, and now it's accessible and can get the benefits, right, of having this type of solution.
That's great. That's great. And so then where does the Arduino IoT cloud fit into this story as well? Not only today, but also sort of what Arduino is thinking long term. Because obviously the reason we do connectivity is because there's some business value we want to communicate on the other end. So where does that connect for you all?
Absolutely. So just to give some context, right, to kind of to the attendees here, Arduino Cloud is something that we released a couple of years ago as kind of an add-on
Hmm.
to kind of the Arduino portfolio of connected products, whether they are boards or finished products. And mainly Arduino IoT Cloud is a cloud platform for IoT that brings three main capabilities, right? The first one is actually providing developer tools to interact with Arduino
Hmm.
devices both locally or kind of over there. So you can create your Arduino kind of sketch in Arduino Cloud and be able to push it serially on your device or do over there update directly. Arduino Cloud is a device management platform so that you can actually remotely manage your fleet of devices that are connected, and it's also an application enablement platform. So you can create both dashboard and analytic experience within Arduino Cloud itself, or it can act as a data pipeline, right, to feed
Hmm.
data in a managed way into
Hmm.
your kind of analytics platform on the cloud and so on. So it's a combination of
Hmm.
three things, and coming with dedicated templates to kind of Opta for being able, for example, right, to use Opta as a Modbus gateway, right, for example, or to use Opta for as a remote monitoring device for with analog sensors. You can directly have a one-click deployment experience where you log in and you subscribe to Arduino IoT Cloud. You start from an Opta template, you deploy the template, it generates automatically the sketch. You can modify
Hmm.
it and add your own capabilities. It gets deployed over there to your Opta, and there you go. You can have your connected experience throughout the entire life cycle of the product, which is really the game-changing
Right.
part.
Absolutely. And obviously with connectivity, and I'm gonna start pulling in a couple of submitted questions that we got when folks registered for the webinar. But this is a good segue because when we talk about connectivity, security always comes up, and I know that's something that Arduino has thought about in general for the Pro line, but also specifically for the Opta. So how do you all manage sort of the security aspect of devices in your ecosystem?
So we kind of try to cover all the basics and what you expect today
Hmm.
from our platform. Of course, every Opta comes with a secure element that stores
Hmm.
unique identity and certificates on the device that are actually managed and negotiated with the cloud platform through a secure provisioning workflow that works. Doesn't matter if you provision the Opta locally or you do it over there. And then, of
Hmm.
course, right, the connectivity is encrypted and the device is really engineered, right, in a way that is can be as easy to deploy. It kind of follows all the de facto security standards for any
Hmm.
microcontroller based kind of finished product, and can be managed throughout the life cycle, which is actually not as often as it should be covered in the security chapter, right? The ability to do over-the-air update for a device is a key foundational feature to make sure that your
Agreed.
device is secure, right? Because we don't know, right,
Absolutely.
what is going to be the new vulnerability that is going to be discovered in 2 years. If you can do over-the-air updates of that device, you can secure that device. You can patch that device. If you don't
100%.
have the ability to do
Yeah.
that, you're screwed.
Absolutely. Yeah. Yeah. And we have a similar, for the person that asked the question, we have a similar approach at Blues. The product inside of our expansion is our core module, the product, our system on module device that we sell called the Notecard. That's in all of our products. And one of the key features of the Notecard is that there's a secure element on that product as well. So when you're going through the process of getting a Notecard, taking it out, getting it connected to our cloud service, there's a secure element on. The keys are baked in at the point of manufacture. When the device wakes up, it knows where to go. And just like you said, Marcello, we have a very similar approach that's complementary with Arduino and the IoT cloud of not only being able to perform firmware updates on the Notecard itself, but host firmware updates as well, because that's a critical piece of it, is that you can actually securely, safely reach into the device to patch a vulnerability, fix a bug, whatever it might be, moving forward. So yeah, I completely agree. I would love to hear, the Arduino perspective on. I think I would expect one of the challenges when expanding into the pro market is hearing just the answer to the question of, okay, well, how is Arduino? How can you assure me that you guys are ready to to solve pro problems? What are how can you give me the assurances that this is a solid set of devices that I can rely on beyond a prototype? So what do you typically say when you're asked that question?
I think that there are two parts, right, to my answer. The first one is that like they say, right, we eat our own dog food, right, and so we this is not the first device that we build, right, and just to give you some number, right, to this day, Arduino has built and shipped something along the lines of 50 million devices over the 15 years of its history, and we control
Hmm.
manufacturing, and we manufacture this as well as the rest of the Arduino portfolio devices in Europe, right, and specifically in Italy.
Hmm.
And so we have a very tight control on quality and on manufacturing, criteria, and therefore, right, we really understand, pretty well, right, what a professional or an enterprise grade type of device, an industrial grade type of device, is required to, to be in order to be kind of, a credible, value proposition for customers. This is the first part. The
Hmm.
second part is that we learn from real world customer example and from real world customers. As I said at the beginning, one of the very reasons why Arduino Pro was born in the first place is after observing that our customers were using our non-pro devices in production, right? And so we
Hmm.
looked
Hmm.
very closely at what they were doing, what they were the gaps that we're finding, what were the challenges that maybe they weren't even realizing, and we focus on
Hmm.
addressing those for our pro devices, and everything from long-term support of libraries and software to the sourceability of the components for long-term availability, and everything that you expect from industrial grade architectures and industrial grade hardware is something that we specifically address in the Arduino Pro line of products.
Absolutely. I think one of the most powerful things that I've seen from Arduino that I really like is that you all you have an answer to, I think, what became the sort of age-old idea for both Arduino and for Raspberry Pi, frankly, of, well, you could use that to build a prototype, but then you got to throw it away and start over. And the fact that you all took the time to figure out, well, why is that true? Why do people feel it's true? Or in the case of some, like you said, why did people go ahead and go to production anyway? And what gaps do we find there that we can help them? But to have an answer to that, to say like, no, you don't have to throw it away. We can actually give you the trust and the foundation to start from the beginning. And I've seen that resonating in sort of the customers and developers that I've talked to, and I think that's a powerful narrative to have. Related to that, one of the questions that we got from the audience was a two-parter from a person who basically said, thank you for simplifying life and enhancing our product's performance, which is great. Always a good thing to hear. But really, two questions for you. One is, can we make the Arduino ecosystem water resistant and possibly fireproof and yet affordable? Was the first question. And then the second is, can we have a 3D printable Arduino, which I think we've kind of answered a little bit, but I'll let you take that one.
Well, of course, right. You can take an Arduino board, both the Pro line and the regular line, and use 3D print your own case, for it. There are also commercial cases out there that you can get, but in the case of Opta, you don't really need it because it already comes with with a case, right? And so there
Mm-hmm,
is no
mm-hmm.
literally no need to 3D print anything, because this is meant to be a finished product, right? A product that it's not doesn't have to be implemented; it just needs to be deployed and configured. Right. And then going back to the
Absolutely.
first part of your question, of course, this is a PLC, and is something that is meant to be installed in a in a panel, right, on a DIN rail. And so as it happens with this type of devices, you achieve water resistance and fireproofing with choosing electrical panel that is IP68 and is ATEX and fireproof and whatever, right? So this is
Mm-hmm,
not
mm-hmm.
something that we address in a peculiar way, right? This is just a common pattern for for industrial automation. At the same time, our Pro line of product is not just about Opta. You can get the Arduino industrial SOMs, and you can integrate that product into kind of whatever case, whatever enclosure that might address your needs for water resistance and fireproof.
Great. Yeah, one of the other questions we got is related to the Opta and its expansion ports, and I'll field it to start because it's related to our expansion, but also your expansions in general. And that is, does the Blues expansion connect to the Opta via the aux port or hardwired? And it's actually kind of a both and. This is an important distinction to make, is that the Opta's aux port provides serial and I2C communications and 3-volt and 5-volt logic levels. But for any expansion, I think this is true. It's definitely true of ours. Is that you're supplying 12 to 24 volts from your power supply into each of those expansion ports as well. And then from that point, then you get all of the comms come across over that aux port. What I think is really interesting, and Marcello, maybe you can unpack this a little bit more, is that aux port does provide I2C. So for communicating with our expansion, it's all I2C comms to talk to the Notecard and send data up to the cloud, and working with our integration with you all as well. But for the other modules, there's also this firmware capability baked in where it can actually handle sending messages down to other chained expansion modules. I'd love to hear a little bit more about how that works.
Absolutely. So basically, if you look at the head unit, of course, has the auxiliary port on only one side. But if you look at expansions, they actually have the expansion port on both sides, because actually, with the expansion ecosystem of Opta, we support daisy chaining, right? Because of course, right, you might need connectivity and kind of expanded IOs, right, or maybe other type of of expansions down the road, and we wanted to give that opportunity and that possibility to customers. And so, in our connectivity protocol, both in our connectivity architecture for the expansion of Opta, we actually implemented an enumeration logic that supports different a certain number up to 8, if I'm not mistaken, expansions, right, that can be daisy chained together and can be seamlessly, right, working and interacting with the head unit just by being connected with expansion port.
Oh, that's really neat. Let's see, one of the other questions that we got here, which I think is an interesting. Oh yeah, about supply. So how does a obviously supply chain around the world, just figuring out where to buy devices, whether it's Optas or expansions. How does Arduino typically provide the Opta for its customers? What are the places that one can buy one?
Absolutely. I think that there are, mainly 3, places, right, that where you can find Opta, and along with, every Arduino device, of course, there is the Arduino store, which is kind of the direct, store that Arduino has. You can find Arduino devices on Amazon, and an increasing number of professional educational customers are buying, Optas, out of Amazon. But I would say that for this type, especially for this type of automation, equipment, the main distribution channels are actually, tier 1 distributors and dedicated automation distributors, right? Such as, just to name a few, right? Avnet, DigiKey, Mouser, RS Components, and I could go on and on, because we have a pretty extensive, both geographically and vertically aligned ecosystem of more than 300 channel partners that can resell and are reselling Arduino devices, including Opta.
Yeah, and for Blues, for our expansion, we'll be launching our expansion with an Opta in our store later this summer, and then in Arduino distribution channels later on in the year, probably in the fall, as we get more products available and things. So definitely, keep an eye out for that for those that are interested. There's a question here about non-internet, non-cellular communication possibilities, and I know LoRa is definitely one thing that we're interested in, and we'll have versions, and a LoRa version of the Opta as well as a cellular version. I would love to hear from Arduino's point of view, what are you seeing in the LPWAN space as well, in addition to cellular, in addition to Wi-Fi and other connectivity options?
Yeah, there are many, again, many different scenarios that we are seeing. I think that agriculture is one, but also being able to do wireless connectivity within the industrial, within the expansive industrial setups, right? For example, right, oil and gas, right? There are companies that want to monitor equipment across a vast, right, area, right, with devices that are kind of distributed across this area, and they don't want to have cellular connectivity for all these devices, because they want to keep the connectivity under control, or they want to take advantage of public LoRa networks, right? And in both scenarios, I think that the ability to tap into kind of LoRa as a technology is a very interesting added value.
Great, definitely. So one final question from me, and then I'll give you a moment to answer this one, and you can share any other closing thoughts as you have them. But as chief product officer for Arduino, obviously you're thinking about a lot of different things across hardware, across your cloud services, around opportunities, not just in general with pro, but also in your education business and the maker business. But I would love to hear in the pro space, like what can you share that's what's next for Arduino in the realm of industrial automation?
So we have so many things, right, that we have, we're working on and we're excited to release. One thing that I can say that one of the area of heavy investment for Arduino is, Opta, not just as one product, but as an ecosystem, right? And really, and
Mm-hmm.
the fact that we
Mm-hmm.
are here, right, talking about, the Opta expansion is a testament to that. Really creating an open ecosystem around, Opta as a platform, so that third parties can build their own expansions to be able to kind of really augment, right, the capability and provide more comprehensive ways of connecting industrial equipment and devices. It's really one of the key area of focus for us, and we think that it's one of the areas that will generate the most value for customers, that will have many more options of addressing their scenario, all with the same low bar of entry. That is really what makes a difference
Mm-hmm.
for them to be able to access the benefits of such solutions.
Oh, that's great. So as you were talking, I decided I might have another closing question for you, since we still have a few more minutes. But I feel like I'd be remiss in any setting like this not to ask the typical AI ML question. And I know it's something that you guys think about because you have devices in the NICLA space that actually solve some of these problems. So what are you seeing in industrial as it relates to the AI ML opportunities for some of your customers?
Absolutely. I think that AI, especially, it's a big topic, right? It's definitely at the
Yeah.
at the peak of hype. I would
Peak
say that
hype. Yeah.
AI in the
Yeah.
embedded space is probably a little bit behind, not because of the technology, but because of the framework, right? And the technology is there, but it's
Mm,
not as accessible as, for example, right, AI technology on the cloud. And so one of our focus is really to lower the access bar to be able to take advantage of those capabilities. And the scenarios that we are seeing the most is of course inference and the edge, whether it is on image, on audio, or on signal. And as a matter of fact, right, there are very common ML framework that are running on microcontrollers that Opta is perfectly compatible with, because something that we haven't mentioned
hmm
is that
hmm
inside Opta has a high-end STM32H7 microcontroller, which is
Right.
one of the most powerful on the market, dual core, that is perfectly capable of running inference workloads directly on the edge. And we have
Absolutely.
samples and
Yeah.
frameworks that can be deployed today on Opta, right? And so of course, right, we are working and we will be working on further democratizing access to these technologies. But this, we're not talking about something that is in the future, right? We're talking about something that you
Right.
can do and anybody can do today.
Absolutely. Well, and at Blues, we've always been big fans of edge inferencing, and starting in our bones and our sort of original genesis was in cellular IoT, where we felt like cellular was a great backhaul for the decision, the inference that you made from a device, but the actual edge devices, as they became more powerful, that was the place to be able to make decisions and then to figure out a way to sort of pipeline raw data elsewhere for model retraining and things like that. But that we have such powerful microcontrollers out there now that can do really, really amazing things, and a lot of techniques for making models that are even smaller than ever before. So I think it's exciting to explore some of that even in the industrial space. I know things like worker safety are a common concern, especially around vision-based applications. And so worker safety, compliance, things like that, I do definitely do tend to come up a lot. And it's great to see that Arduino is thinking along those lines and working in that space. So that's great. Well, Marcello, thank you again. I appreciate you taking the time to chat with us, and thank you everyone for joining. That is it. We're going to sort of sign off for the day, but thanks again.
It was a pleasure to be here. Thank you, Brandon, and thank you, everybody.
Take care.